In this video we're going to go through the Octet Rule, but spend most of our time on exceptions to the Octet Rule, because those are critical to understanding organic chemistry and the various molecules that you'll see. The Octet Rule basically states that any atom wants to have an electron configuration like that of the noble gases. So for instance, xenon has 8 valence electrons and it's very stable. Carbon, on the other hand, has 4 valence electrons, kind of unstable, therefore it wants to bond with other molecules such as hydrogen, which each contribute 1 electron, so that the carbon can bond with each hydrogen and kind of borrow its other electron. So it seems like carbon has 4 electrons and each hydrogen has 2 electrons, making each one happy. Now, exceptions to the Octet Rule are the most important. Some of the exceptions are phosphorus, sulfur, and chlorine. Those are the ones that you'll see the most often. These ones are exceptions because they're on the 3rd row of the periodic table, the 3rd period, and because they're down so far in the table, they have d orbitals that they're able to access. Therefore, they could have an expanded valence or more than 8 valence electrons. Phosphorus, for instance, you might see it in H3PO4. Now, if we were to bond each oxygen to the phosphorus only once, the phosphorus would have its 8 valence electrons and it would be happy. Each oxygen could get a hydrogen, but this oxygen right here would be missing a hydrogen, and therefore it would have 3 lone pairs giving it a negative charge. But we don't see a charge in this molecule. And that's because there isn't a negative charge. What actually happens is oxygen is able to donate these lone pairs into a double bond with phosphorus, making the molecule look something like this. O double bonded to P with 3 OHs bound to it. That's the shorthand for it. Sulfur is a similar one. You might see sulfur in sulfuric acid, H2SO4. Okay. If we were to write that out, sulfur has 6 valence electrons, 1, 2, 3, 4, 5, 6. We have 4 oxygens bound to the sulfur. 1, 2, 3, 4, 5, 6 electrons there. Got one right here. 1, 2, 3, 4, 5, 6. Oxygen. 1, 2, 3, 4, 5, 6 electrons. Finally, our last oxygen. I'll sneak in there. 1, 2, 3, 4, 5, 6. Now, if we want to satisfy the valence of each oxygen and each sulfur, what we're going to have to do is actually double bond both of these oxygens to the sulfur. Use a single bond for this oxygen, add an H here, and do the same over with this oxygen. Double bond and add an H with an electron. It looks messy, but basically what's happening is we're making this molecule, HOOH. And we could see that there would be 1, 2, 3, 4, 5, 6 bonds to sulfur. Finally, the last exception to the rule would be chlorine. Chlorine, you might see an expanded octet in something such as perchlorate. That's ClO5 minus. ClO4 minus. Now, in order to satisfy the octet of every oxygen and the chlorine has 7 valence electrons. We have 4 oxygens. We could see pretty quickly that we're going to end up double bonding 3 of the oxygens like so, and single bonding another one of the oxygens, leaving it with a negative charge. That's about all the exceptions for the octet rule that you're going to be seeing in organic chemistry. Make sure that you're familiar with these and are able to draw out the Lewis dot structures when you see them.